Another kind of loop available to us is while loops. So while loops can be used just as for loops are for all of the same things, but we have to set them up in a little bit different way. And because we do that, they're better suited for some tasks than for loops, but they're also not as good as for loops for other tasks. So let's talk about a conceptual example first. Imagine that you're taking a test, and that test has 10 problems. One way to do this with our for loop would be doing a loop over each of the problems. So for problem in test, solve that problem. So first I'm going to solve problem number 1, then I will solve problem number 2, 3, 4, all the way until we're done with our test. So we're iterating over an individual value, this sequence that in this conceptual example is the different problems within our test. We could also think about doing this in terms of a while loop. So while my percent done is less than 100%, increase my percent done. So am I done with the test? Am I 100% done? No? All right, work a little bit more. Work for 2 more minutes. After those 2 minutes, am I done yet? No? Okay, work for 2 more minutes. So the difference here is that when we're taking the test using a for loop, we've already broken things into some chunk that we know at the beginning we have this much to do. We have 10 problems to do. With a while loop, we're going to do something until a condition is met, or a condition is now going to be false. So, or is set up. Sorry, let me back that up. We're going to keep running the while loop until whatever condition here is not true anymore. So until percent done is equal to or greater than 100%, I'm going to keep doing the things within this loop. So let's look at an example here. We have to do a little bit of setup. Oops. Sorry. I'm going to say push to large is 0. And I'm also going to create a counter at 0. So push to large I'm going to use as my convergence criterion. So I'm going to have a while loop, and I'm going to say while push to large is less than 6.5, do this stuff. So these things that are tabbed over, these are in the while loop, and these things will happen over and over and over until push to large is not less than 6.5. So as soon as push to large is equal to 6.5 or greater than 6.5, we're going to be out of our loop. So the reason that I have a counter is that with our while loop, we can't use the indices as directly as we can with the for loop. So if you remember up here, we're setting up our for loop using indices. So that way when I call some numbers at spot, I can use that index, and it's always going to keep going up and up and up. Right? So spot goes from 0 to 1 to 2 to 3 to 4 to 5. We don't have that with our while loop. And so I need to use a counter. So counter starts out as 0, and every time I go through my while loop, I'm going to push counter up 1. Counter is equal to counter plus 1. So the first time through, counter is currently 0, go into the loop. I'm going to do this, and then I'm going to add 1. So at the end of loop number 1, counter is 1. Now if push to large is still less than 6.5, and I go through this again, then counter is going to go up to 2. And so we're going to be able to iterate through some numbers using counter that we're adding up here. So that here, push to large is equal to some numbers of counter. So I'm going to iterate through what some numbers is. And let me just print some numbers to remind ourselves what that is. So -1, 4, 6, 3. So the first time through, counter is equal to, push to large is equal to 0 and counter is equal to 0. So while push to large is less than 6.5, so 0 is less than 6.5, let's go in here. Now we're going to set push to large is equal to some numbers of counter, which is 0. So now push to large is -1. Counter is equal to counter plus 1. So now counter is going to be 1 because it was 0 and now it's 1. And then we're going to go back up here. Is push to large less than 6.5? Well, push to large is -1, so yes, that's less than 6.5. So we're going to do this loop again. So push to large is now going to be equal to some counters, or some numbers of counter. Counter is now 1, so 0, 1. So now push to large is 4. So we're going to keep moving up here, and the way that we iterate through is by using this counter. And we're going to keep moving down until we get to a number that's greater than 6.5. And the first one that's greater than 6.5 is 9. So you'll note that my push print to large here, 9, that's the first time that any of the values that we gave it here with push to large as some numbers with counter iterating up is greater than 6.5, greater than or equal to 6.5 is 9. So that's what returns. So while loops can be a little bit dangerous, right? So this is going to keep iterating forever and ever and ever until it finds some value that makes this false, right? So while this is true, it will keep going. So if we didn't have a 9 here and the 7 wasn't here, it would keep going all the way through our index. It could run indefinitely. Right, so let's take a look at this. And the reason that it's commented out is that we don't want people to accidentally run it and not know what's going on. Okay, so we're going to set counter equal to 1 to begin with. And then while counter is greater than 0, counter is equal to counter plus 1. And then print counter. So if we think about this, counter starts out as 1, and we're always adding 1, so counter is always going to be greater than 0. So let's run this. You'll see very quickly that it just keeps going and going and going and going and going. I'm going to use the stop button up here to stop this, right? So just in the few seconds that we did that, we got all the way down to, what, 44-ish thousand times through this loop. So this can be very dangerous, right? This can be either because our problem is ill-posed, and even though we've coded it correctly, we'll never reach this criterion. Or it could be that, you know, I'm having an off day and I just didn't put things in correctly. So just be careful with while loops for this reason.